Good morning, students. So today we will be learning about number system. As you can see here, I have written the learning objective as to understand real numbers, and the success criteria is student will be able to know the difference between rational number and irrational number. So by the end of the topic, we will be able to know what is the difference between rational and irrational number. So let's start the topic. So as you have already seen the topic here, number system, and you've already come across numbers like natural number. So when we say natural number, all the counting numbers are called natural numbers that we have come across in our lower classes, like 1, 2, 3, 4, 5, 6, and so on will be called as natural numbers. Then we have seen whole number. So what do we understand by whole number is when 0 is introduced with natural number, 0, 1, 2, 3, 4, and so on. So this series of number is called whole number. So now again one more number system we learned in our lower class, which is integer. And integer was all the negative numbers combined together with whole numbers is called integer. So all the negative numbers and the whole numbers give rise to integer. But in this topic we will be learning something new, and that is called rational number. So we should have the knowledge about natural number. Natural number means all the counting numbers or numbers starting from 1. Whole numbers means numbers starting from 0, 1, 2, 3, 4, and so on. Integer means all the negative numbers and positive numbers including 0. So what is rational number then? So if you go into the detail of rational number, let's see the definition of rational number first. So the definition of rational number tells any number, any number which can be written, which can be written as p by q, where both p and q are integers and q is not equal to 0. So this is the definition of rational number, is called a rational number. So any number that can be written as p by q where both p and q are integers and q is not equal to 0 is called a rational number. So for example, we can say 1 by 2, because 1 and 2 both are from integers, both are positive integers, and the denominator, which is this 2, is not equal to 0. You can take another example, minus 3 by 5. Again, minus 3 by 5. Minus 3 is an integer, negative integer. 5 is also an integer, but the denominator 5 is not equal to 0. See one more example. Let's take 3. And just a while ago, we learned that 3 comes under natural number, whole number, and integer. But 3 also will be called rational number because it is following the definition of rational number. And the definition of rational number says that any number which can be written as p by q, where both p and q are integer and q is not equal to 0. You can take one more example. Let's take negative integer minus 3. Now minus 3 also is a rational number because minus 3 can be written as p by q, where both p and q are integers and q is not equal to 0. So from here we can conclude that whatever we learned about natural numbers, or all those numbers that come under natural number, ultimately can be called as rational number, because all these numbers can be written as p by q. Let's go back to whole number that we learned, 0, 1, 2, 3. So all these numbers also can be written as p by q. Then let's take an example of integer, -3, -2, -1, 0, 1, 2, 3. Even all these numbers, integers, can be written as p by q. So from here we can conclude that whatever we learned in our lower classes like whole number, natural number, whole number, and integers, all together we can call them rational numbers. Now, if you ask why, because all these natural numbers, whole numbers, and integers can be written as p by q. So that's the reason we can say natural, whole, and integers are rational numbers. Now let's take one more type of example, because the definition says any number, and number doesn't end only in natural number, whole number, and integers. There are something called decimal numbers as well. So let's take an example of a decimal number and see whether a decimal number can be called a rational number or not. So the only criteria for a number to be a rational number is it should be in the form of p by q. So let's take an example of a decimal number. Let's say 1.35. And we have learned from fractions and from decimals that if after decimal there are two numbers, we can write this number as 135 divided by 100, because after decimal there are two number. Hence, if I divide the given number by 100, I'll get back my given number. So we just have to see how many numbers are there after the decimal. If just it's one number after the decimal, we can write 13 by 10. So we can say that all the decimal number which are in the form of terminating decimal number, terminating decimal number. Terminating decimal number means a decimal number which is coming to an end, because after 5 there is no other number coming. Hence, we can call this kind of decimal number as terminating decimal number. So, all the terminating decimal numbers are rational numbers. Why we can conclude this? Because any number which can be written as p by q, where both p and q are integers and q is not equal to 0, is called a rational number. So any number which follows the definition of rational number becomes a rational number. So hence here also 1.3 we can call it as a rational number, because 1.3 can be written as p by q. Okay, let's see one more type of example. Let's take a decimal number only, but this time let's take a non-terminating repeating decimal number. Example. So what do we understand by non-terminating repeating is non-terminating repeating decimal number. So example for non-terminating repeating will be something like this. Let's say 1.6 bar. So what do we understand by this 1.6 bar? Means it is 1.666, means the number 6 is repeating. That's why we call this kind of decimal numbers as non-terminating repeating decimal number. Now, as I said, even non-terminating repeating decimal numbers can be called rational, because we can convert this kind of decimal number in the form of p by q. So let's see. I'll show you a direct method where we can convert a non-terminating repeating decimal number in the form of p by q. So we need to write all the numbers, whatever is given here. Then we have to subtract by that number which is not on bar. So we just have to subtract the given number by that number which is not on bar. Then after decimal, how many numbers are there? 1. So I have to write 10 here and subtract with 1, because after decimal the bar is there. So had it been like this, let's say 1.46 bar, then in this case it would have been 146, right? All the number subtract with that number which is not on bar, divided by 100. Why 100? Because after decimal there are two numbers, that's the reason we have to write 100. But this time I will not write 1, because after decimal we are leaving one number and then the bar is there, so we are leaving the 10th place number. This is called the 10th place number, this is called the 100th place number. Hence we will write here 10. So we should know the difference ki why we are subtracting here by 10, or why we are subtracting here by 1, and why we are subtracting here by 10. So I'll again repeat. If after decimal one number is there, we write 10, and just after decimal if the bar is there, we write 1. And if you ask how the 1 came here, the reason is we need to write down all the given number as it is, subtract with that number which is not having bar. So if I come here, it is 1.46 bar. So I'm writing all the number, subtract with that number which is not on bar, divided by 100, minus why 10. If you ask me, because after decimal one number we are leaving and then the bar is there, so since we are leaving the 10th place number, that's why 10. Had it been bar here with 4 and 6 together, I had to write 1. So that we have to understand. So now if I subtract this, I'll get 15 by 9. That means I am able to write this non-terminating repeating number as p by q. That's why, and both p and q are integers. That's why I can say all these non-terminating repeating decimal numbers are rational numbers. So we need to be completely clear about the definition. Then only we will be able to know what is a rational number. So now let's see what type of numbers are called irrational then. So we have seen that any number which you can write as p by q is called a rational number. So all the natural numbers that we have learned, all the whole numbers, all the integers comes under rational number. Now let's see what type of numbers are called irrational numbers then. So the definition of irrational number is any number which cannot be written, which cannot be written in the form of in the form of p by q. So you take any number, and if that number cannot be written in the form of p by q, we call that number as is called an irrational number. So let's see a few examples. Let's see an example of, let's say, root 2. So when we find the root over of 2, we get a new number, and that is 1.414 dot dot dot, means numbers are still coming. This dot 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 represents numbers are still coming, and this kind of decimal numbers are called, because we can see here decimal point, this kind of decimal numbers are called non terminating, non repeating. Because if you see here, numbers are not repeating. When we can say numbers are repeating, if it is 1.666, if it is 1.414, 414, 414, like that, then we call those kind of numbers as repeating. So non terminating, non repeating decimal number. So this kind of decimal numbers are called non terminating, non repeating decimal number. You can take again example of root 3, 1.732, again dot dot dot. Same reasoning, non-terminating, non-repeating decimal number cannot be written as p by q, because we don't know after decimal how many numbers are there, first thing, and they are not repeating. If they were repeating, we could have used the earlier method. But since we don't know after decimal how many numbers are there, and we even don't know after decimal when they will repeat, so since we don't know both the cases, we will not be able to write this number as p by q. You can take another example as pi, which is pi value is 3.14 dot dot dot. Even pi is irrational, because we cannot write pi value in the form of p by q. So basically all those numbers which you cannot write as p by q are called irrational number. And so From here, we come to the main topic, that is real number. So from here, we can say that combination of rational and irrational number is a real number. So when we combine rational and irrational number together, and the number that is called a real number. So real number basically is combination of rational and irrational number, or in other words, every point on the number line on the number line is called a real number. So we can get infinite rational and irrational numbers on the number line. Infinite means uncountable rational and irrational numbers we can get on the number line. So the definition of real number says that combination of rational and irrational number turns out to be real number. So every point that we get here in the number line represents a real number. So here the points are either rational or irrational number over here. So that's why combination of rational and irrational number is called a real number. So we'll end the topic for today here. So please go through the definitions and ask me if you have any doubts. Thank you so much.